Well, I'll warn everybody, I thought we had about an hour, so that's about how long this might be. I can shorten it and just let you ask questions. But I am Jon Arthur. I'm the director of the Florida Geological Survey, a division in DEP, and also the state geologist of Florida, and was asked to share with this group, much like what you just heard, an overview of what we do within our agency. And I'll just jump right in. So Statute 377.075 gives us some direction, and that was from decades old. But I was, I'm always impressed to read it and think back. They were really thinking forward. They were thinking ahead in terms of the importance of geology, geoscience, hydrogeology, water quality, geologic specimens, etc., collections. So this is a synopsis of what that statute states regarding conducting, laboratory and field investigations, focusing on geology and hydrology or hydrogeology, and maintaining geologic collections of all kinds, and working with other partners both within our agency and outside. Also acting as a clearinghouse for geologic information across the state, maintaining a library, and conducting various mapping and analyses type exercises and studies, and improving our overall geology of Florida, our understanding of geology of Florida, excuse me. And across the last couple of decades, these are some highlights that we've been involved in, just to kind of give you a high level look. Early in the 2000s, we were very active in aquifer storage and recovery and water rock chemical interactions, and helped avert delivery of arsenic groundwater to drinking water supplies. That also was information that fed into the present design of the Comprehensive Everglades Restoration Plan, which has been through its own evolution. Also, we did a great deal of work across more than a couple of decades with regard to the environmental challenges that were being faced by springs, with regard to exotic species and water quality issues and flows. And on a more specific level, sometimes people propose to do things in certain parts of the state that just aren't great ideas, like where you place a landfill and where you don't. And most recently, a couple of years ago, we completed an assessment working closely with Dewberry of statewide LIDAR that informed the legislature and the process, and I think helped lead to the funding of the current statewide QL2 data collection for LIDAR. And so, when we see a statewide need, that's something it's our responsibility, my responsibility to identify, that has something to do with geoscience, and we do what we can to tackle it. That's a long list of needs, but we're making progress. So our mission statement within the FGS is to collect, interpret, maintain, and distribute objective quality geologic information to benefit Florida. And with regard to the organization of our division, that includes, the administration side. And rather than talk about our individual sections, I've just kind of regrouped it by samples, data, information, and also research and mapping. And these elements I will then expand on further in this presentation. I won't talk a whole lot about administration. It's, that's what keeps all ships on course in terms of HR and budget, etc. But they play a huge role at the FGS and outreach and communication and production of our newsletter. And so that's a lot of activities that we do here. The Earth Science Week, we just had an open house this past Friday with about 250 people that came through. And we have 3 times a year, we now put out a newsletter that reaches about 16,000 people, and manuscript editing, publications, etc. And just sharing this knowledge with all interested is one of our charges. Also, in the past year or so, we have reinitiated the designation of state geologic sites. Before I came on as director, there were just a handful. So last December, well, in the last couple of years, we identified criteria for naming state geologic sites at a very high level. You see those here on the slide. And then started the process of designating new sites. And last December, we designated Wakulla Springs State Park. And just 2 weeks ago, we designated Falling Waters State Park in the Panhandle. And these are, the best examples of what they depict with regard to geology. And they won't all be state parks, but we're starting with state parks in recognition of our partnership here in DEP with them. But there are other sites across the state that we're considering, and all totaled, we'll probably look at about 15 some odd sites that would be that would receive this designation. A little bit more about the sites that exist already. Windley Key Fossil Reef State Geologic Site, which is down in the Middle Keys. It is a state park, and you can go stand in a 12,500-year-old coral reef, fossil reef. I'm sorry, 125,000. Devil's Mill Hopper Geologic State Park, just north of Gainesville, basically a sinkhole that's created its own ecosystem. Florida Caverns, of course, and the last two I just mentioned. With regard to data collection, in order to understand subsurface processes, whether that's geology or hydrogeology, aquifers, etc., on a statewide, regional, or local level, we need to collect information, of course, and we are equipped to do that here at the FGS with 2 drill rigs, actually 3 drill rigs that have various applications for deep and shallow coring and drilling and development of monitor wells, as well as an array of geophysical tools that measure optical, physical, and chemical properties of the subsurface rocks and sediment. And we have our fingers crossed about a new rig that is in the current budget package. Hope I just didn't jinx that. We also have an offshore research vessel, a 55-foot, used to be a Coast Guard aid to navigation that can run various towed fish for bathymetry, side scan sonar, sub-bottom profiling, or vibrocoring. And this type of work, both inland lakes and offshore, is very important with regard to, again, understanding mineral resources and even partnering with FWC for habitat mapping and Department of State with archaeological resources. In terms of data management on the physical side, we have a core repository that holds more than 19,743 borehole sets of samples. And these are from single wells, and nearly 9,000 surface samples that have been collected. The replacement value of just these samples has been calculated on the order of $1.6 billion. And it's in a warehouse that is more than 22,000 square feet. And it is ever expanding. So we are constantly looking for space, and then that space, once we receive it, it fills pretty rapidly. You can see our latest expansion here with the shelving. That's on a 2nd floor, so we couldn't put mobile shelves, but you get an idea of the volume that we're looking at. And we're extremely grateful to our partners, including Southwest Florida Water Management District, for helping fund this effort in some small way with regard to shelving or boxes, etc. We have a lot of legacy data. The FGS has been around for more than 112 years, and we are doing our best to make all of that information available to geoscientists through our various portals on the internet and our website, and I'll get into those in a moment. And it's a huge lift. We're constantly pulling out our library very valuable information that gives us historical perspectives on past terrains, landforms, historic air photos, geologist field notes, etc., and 35 millimeter slides, you name it. It's, these are helpful for looking at the health of springs, for example, across time, to see these photographs. And so we're making every effort to pull all this forward and make it useful and discoverable and so forth. So one of the major accomplishments that we've achieved is recently development of a cloud-based borehole data system, and it's called the Geologic Data Enterprise System, or Geodes. And we haven't really told the world about this yet because we're still building connections to a lot of this data and information. But about this project, this replaces our legacy borehole database with lithologic and geophysical logs, as well as our surface sample collection. And it migrated all of this information from our Microsoft Access system, which was just slow and cumbersome, into a software as a service cloud-based solution. And it currently exports regularly to our Map Direct Focus online, so you can pull these up in a GIS. It is built, it's operational. Like I said, we haven't rolled it out because of some of the many data collections or data connections we would like to still make before telling the world and letting them see how wonderful this is. And it's also a unique system in that, unlike any other state survey that I'm aware, it enhances our operation. So it's not just managing borehole information and feeding into a GIS. It's helping us with our inventory, our catalog, which core is on which shelf and which little corner of the warehouse, and so forth, as well as sample receiving, and it has connections for various research projects, publications, and various collections. So, for example, we know which core has thin sections or hydraulic conductivity analyses run, etc. This is a screen grab from that system, and it's developed by Kyra Solutions, so the website actually has their address, and it puts you into the cloud platform. And the search criteria they're pretty basic on this thing, because the real power is when you click on map and then you explore the data, all of the data we have through the map portal, and various ways to access information. On the right, you see under actions little icons for Excel file exports, PDF file exports, or text. And within all of these are hyperlinks where you can drill down and acquire more information. And I'll talk about that more in a bit. Our information management, we still, per statute, have a library, and the FGS has produced about 884 publications, maps, posters, videos, you name it. And the library has primarily holdings that are not readily available online. And we also maintain subscriptions to various databases and selected journals. And that, I think, is the real power of our research library, especially for folks in DEP. Send some keywords in, and our archivist can fill your inbox with journal articles and abstracts, or at least a list to sift through and see what you're interested in. But it's an invaluable resource for our in-house scientists, as well as anyone else who wants to reach out to us and make an inquiry. So we have, in terms of our geoscience work, we have two main areas. One I call core geoscience, and as it mentions in the statute, just characterization of the mapping, the geology of the state, and that is geology, geomorphology, etc. And then there's the applied geoscience, and that's where the rubber hits the road. That's where we're actually applying geoscience to solve environmental problems, and I'll talk about that in a bit. From the core geoscience side of things, we are in the midst of completing the statewide geomorphic mapping project that is refined as we go by LiDAR that's being collected, and these are the regional districts as well as the more localized terrains. And this type of mapping is invaluable for land management plans, habitat conservation, land use. And this next slide, we're going to zoom in and just take a look at the red square in the panhandle, just some of the detail of the geomorphology terrains that are mapped within that red square. And then, of course, the smaller red square, this came from our event last or 2 weeks ago at Falling Waters, some materials we put together for the park. But this is the local geology at Falling Waters. So the small red square relates to the geologic map on the right, and the big red square is the geomorphology terrains. And we are shooting for having an online atlas of the geomorphology coming up in the next 6 months or so. And then a larger full-scale bulletin document that would follow in the coming years. But we realize that as LiDAR becomes available, this is going to be enhanced and become even more accurate. So we're sort of realigning our approach on this until we have statewide seamless LiDAR. Many of you have heard of the state map. It's the State Geologic Mapping Program, and it's a partnership between every state and the U.S. Geological Survey, funded by the National Cooperative Geologic Mapping Program, and it's a one-to-one match. Since state map has been since Florida has been involved in state map, we've received $2.9 million awarded to Florida through the program, and we've matched it penny for penny by that amount, and we've got about 55% of the state complete. So and there's been a lot of work done on geologic mapping in terms of return on investment and averted environmental crises, and how deep to drill your wells and where to drill, and mineral resources, water resources, etc. And if you buy into the middle of the range that the economists report, we realize as a state about a $185 million return on this investment of funds in order by just developing these maps. The map you see is a geologic map draped on LiDAR for the Orlando area, and you can see the tiny little index map in the lower right of the map. So state map has been marching on for 24 years, and it's just, there's been 3 staff funding, it's supported by this program over the years, and it's just slow going. So we've initiated a parallel mapping program called Flag Map that more recently I've retitled the Florida Geological Survey Mapping Initiative. And basically we're trying to accelerate the progress on this mapping effort, redirect our internal resources towards this effort, and hoping to get it done by the middle of the 2020s. So that's a very rapid acceleration in this project, but it's pretty important to have completed because of all of the applications in land use planning and geological hazards and so on. And of course, we'll be completing the cross sections that typically accompany the state map products as well. And we're looking forward to building a statewide library of cross sections. And ultimately, I don't have a slide for this, but this will all feed into a 3D model of the state. And that's my, long range vision for where we're headed with all of this. And that would be supported by the Geodes database system, as well as the surface mapping and the subsurface exploration we'll continue to do with our drilling and partnerships with water management districts. So, and speaking of which, we work with the districts quite a bit in describing their wells, and at times we put together regional frameworks and publish those. As you see on the left, that was some work we did 10, 11 years ago with SwiftMud, Southwest Florida. And now we're moving into the applied geoscience arena. And I'm leading with something we touched on this morning, the statewide potentiometric mapping. We too have had some staff turnover, so we've got a new person taking this on, and but we plan to continue to put these maps out twice a year in collaboration with the water management districts, USGS, and some local governments, and even our border states, in order to continue to produce these maps and make this information available. And the maps, of course, are seamless and internally consistent and follow an internally consistent methodology. And we're exploring the idea of developing these maps on regional aquifers. And if there are any water management district folks who want to chime in and state their need for that, I'm not quite sure to what extent, for example, the sand and gravel is mapped, or the Biscayne, or how often, but we're thinking about that, although we do have to watch our resources. So another project that we just completed, and this was in support of the Division of Water Resource here in DEP, was to use the NHD Plus data set from USGS and EPA, and we went out in the field, took numerous flow measurements. Oh, I'm sorry, I got ahead of myself. This is to look at a 72-hour travel time to the city of Port St. Joe surface water intake, which you can see is the northernmost red dot on this map, and this is showing the Chipola and Apalachicola river drainage system. And the whole idea is to build a tool that would allow calculation of that travel time using the NHD Plus information, but we validated that with our own flow measurements and our dye traces, and it wound up very successful, and it also validated that the NHD set was very tight, and we were happy to see that as well. But the final map, which I don't have plugged in here, but it actually delineates the 72-hour travel time. This project kind of got delayed by the Hurricane Michael moving through, and we had to kind of wait on things to get back to some semblance of normal after that. But this was a project, again, in support of source water protection for that intake. Also, we've done some work, again, I mentioned, with Florida Fish and Wildlife Conservation Commission. This is a bit of an old slide, about, I think, 4 years now, but it's I just think it's amazing and cool. The reason is that we were asked by FWCC to characterize the Big Bend Wildlife Management Area, specifically the Spring Creek unit, which is in Taylor County, and because they just wanted to know more about the resources they had in this particular property. And so we looked at, the site description. I'm sorry, I'm getting, okay. So we conducted pretty intensive field work and drone reconnaissance in this area. We made use of all existing information, and it was pretty field intensive. These are not places you want to go just leisurely walking through the woods. This was very thick vegetation and muck, etc. And the field team did an outstanding job on this project. And all totaled, they confirmed 12 known springs within this region and documented 27 new ones. And in some of these, we estimated discharge. Sometimes we measured it when we could, took water quality samples, field parameters, photographs, and really advanced our knowledge of the karst and the springs resources in this area. We also mentioned dye trace projects. We also do this at times in partnership with other water management districts to refine and improve our understanding of spring sheds and how they change over time. A couple of recent examples. In fact, if you live in Leon County, Lake Miccosukee now looks like this again. So it's a good time to go see the lake waterfall, if you will, down into the sinkhole, and also the Cypress Pond Swallette. But these are, routine collaborations that the FGS, engages in with other agencies. We were also asked by Leon County to take a look at the a lake in the county that has historically received stormwater runoff, and they were trying to get their arms around the degree to which the sediments were contaminated and how thick those sediments were. So we conducted GPR across this lake, as well as various coring, vibrocoring, and laboratory analyses to map the thickness of the muck layer within the lake and characterize the sediment chemistry and the leachability of that of those compounds, so that the county could then consider the next step in terms of remediation, whether or not it's needed and to what extent. We also support other parks and counties with GPR. This was about a year and a half ago. Volusia County asked us to come out and look at Gemini Springs. They were having an issue with sinkholes forming and affecting some walkways, and we got out there and provided them some support with that. Also, the Sludge Side in Fort Myers. If you live in South Florida, you've heard of this one, and we ran GPR in the neighborhood and the adjacent empty lot in order to characterize the subsurface. There was some thought that there might be buried metal objects, and also just trying to find the limits of the sludge site relative to the natural, geology, the natural earth, as opposed to disturbed land. And just as an example of our agency support, intra-agency support, we do a great deal of GIS modeling, both on the core science and applied geoscience side. This is the latest rendition of our statewide aquifer vulnerability assessment model that we've completed for the Division of Water Resource Management here in DEP, and this is the third phase of this model, and every time we of course run it, we're enhancing all of the data layers that feed into it, and tightening up the statistics and the validation and the meaningfulness, if you will, of the output. And as you can see here, it's more resolved than if you've seen this before, it's more resolved than prior models. We've also, in the process of doing this, really pushed forward the statewide coverage of aquifer overburden, mapping topographic depressions that are a proxy for a sinkhole coverage that of course relate to vulnerability of the aquifers, and statewide coverage of soil drainage and other soil properties, as well as developed a new layer called the epiphreatic zone, which is the vertical distance between top of rock and top of the pressure head of the Floridan, which was found to be highly correlative with vulnerability and highly correlative with sinkhole likelihood, which is another model that we are working on, and it's in final peer review phase. I don't have a slide of that one, but a statewide model of sinkhole likelihood. On the data and research side, trying to get all of this information at fingertips of the geoscience community and the public and all of our stakeholders, environmental consulting firms, academia, etc. Here's a listing of what is out there. The Map Direct focus that feeds from the Geodes data solution. We have the Geospatial Open Data Portal, our library. We have story maps, such as the one to the right. We put together a Florida Geologic History story map, online catalog of our library holdings, FGS publications, and much, much more, including our recently posted photography collection. So a lot of the great work that's been done over decades with photography, as well as scanning of documents like those old field books and photomicrographs, and you name it. We're trying to put all of those in an online resource called Resource Space, and I can provide that link upon request. We also have quite a bit of coverages. You see here 42 coverages within the DEP Open Data Portal, where you can download this for use within ArcMap. Themed coverages, this is just another way to kind of get at that information. on the DEP website. And there's a sneak, well, not a sneak preview. This is the live feed from Geodes into MapDirect, showing the orange are the hand samples that have been collected across the state. And you'll notice that ribbon along the coastline was the last time we conducted sedimentological analyses for the entire coastline of Florida. And that is to help with matching beach nourishment sediments that are brought in to maintain beaches. And the green are the geophysical logs, and the blue are the lithologic logs. And we hope to ultimately have this type of data reflect all available geologic data across the state, across all agencies. Right now, for example, if you click the green symbols, you'll have access to the older geophysical logs that have been scanned across the state, and a sample is shown there. And with that, that's a big broad brush of what we do. Sometimes we get questions about oil and gas and oil exploration and earthquakes in the panhandle that may or may not be related. And we've post-hurricane, the photograph on the bottom is a shot of Florida Cavern State Park after the hurricane bulldozed its way through, and they had some concerns about damage to the cave system and the entranceway. And with that concludes my presentation. Be happy to answer any questions.
Oh, great. Thanks so much, Jon. Yeah, questions for Jon.
This is Chris at St. John's. That was a really great presentation. I appreciate it very much. Maybe this is a question for Dan. Can we get a copy of the presentation?
Yeah, I recorded this, so we can put it up on the web if Jon Arthur is okay with, but also if, I don't know if you're able to share your slides, Jon. Let me know.
I'm happy to. You can. Okay. It might be easier if people just want me to shoot them a PDF. Okay. There's my email address.
Okay.
If they don't want to bother with a video.
I'll follow up with you on, and we can get the PDF out to everyone.
I would like to share the presentation, so hopefully you don't mind that you've been recorded, because there's more folks here, I think, at St. John's I'd like to share that with.
Okay, great.
Okay, good.
So I'm confused a little bit about what we spoke this morning with when Rick was talking about getting water level data and wind so that we could build these twice annual pop maps, but FGS is kind of going forward with it. And in fact, recently, I know just a month or two ago, we provided the data to, I forgot her name, but she works in the FGS office. I think it was a she. And we're happy to do that, and we turn the request around pretty quickly. So to me, doesn't that kind of eliminate the need to worry about what we were talking about this morning?
This is Rick, and no, it doesn't. The groundwater level percentiles they're based on water levels, but the water management districts have agreed to calculate the percentile for the given month. So it's a little bit different data, but it's based.
Yeah, okay, you're right. I'm sorry, I wasn't thinking that through. So it's more based on purely historical as opposed to the snapshot of the current status.
Correct.
Yeah, good question. I had a question, Jon, about you mentioned the economic value of the statewide geologic map.
Yes.
Can you say a little bit more about how that was determined? I mean, you mentioned land use planning and geologic hazards as being sort of some of the applications there, but can you say kind of who came up with that, or what that economic impact involved?
Sure. So there have been probably 3 fundamental studies that have been done over the years with regard to the economic value of geologic mapping. Bagua and IP, I think, is the most recent paper, and I can dig those up and send them to you. I think the range was between $5 and $50 return for every dollar invested in geologic mapping. And this was based on a study across the country of just how people are using geologic maps. And there's a current initiative to update that. And in fact, I've been very vocal about the process for that. I do a lot of work with the Association of American State Geologists, the National Academy of Sciences, and the USGS. And all of them are involved, or will be involved, in this updated economic assessment. And I think it's very important that the assessment be tied to real dollars and not crises averted, although it's hard to get those real dollar numbers, as we learned when we tried to get the return on investment calculated for LIDAR, for example. A lot of people can talk all day about why it's useful, but to put a dollar amount to it is very difficult.
Right.
But if you use a geologic map to site a pipeline and you do your job well, and then there's or let's say, I mean, I'm not picking on pipelines, but any kind of infrastructure that you're going to site, if you don't do your homework about the earth, you could have some serious problems, whether that's a sinkhole in a landfill, or you name it, and or contamination of liquid petroleum in a karst setting, and impacts on the aquifer. So it's really tough to put dollar amounts on that, but people have, and that's where that number came from.
Yeah. Okay.
And I'm not even getting into mineral resources, which is a whole other piece of that pie.
Okay. Okay. Great. Yeah, I also wanted to say, great job finding new springs. I would have thought all the springs were like known and mapped, long ago, but you found like 30 some springs just in that area.
Yeah, and I really think that's the tip of the iceberg.
I was going to ask if in order for that to happen in other areas, you need some kind of similar study to happen. Is that right?
Correct.
Okay.
Hey, John, this is Dave at SwiftMud, and Sandy had to step out. She saw your presentation, and she just wanted to thank you. And we all have enjoyed the collaboration over the years with the Geological Survey there, and keep up the good work.
Thanks, Dave. Yeah, we've really enjoyed working with all the districts and SwiftMud. You guys have been a huge partner, and we really appreciate it. It's we get spread kind of thin up here sometimes, but we got a lot going on.
Any other questions for Jon? Okay, well, thanks so much, Jon, and thank you, Whitney. I'll follow up with both of you to get your slides, if that's okay. But we really appreciate learning from you today. So thanks for sharing your expertise with this group.
My pleasure.
Yeah, my pleasure.
Great. Well, thanks, everyone. I'll follow up shortly with an email on slides and other info.